What is up, people of today? This is the long-awaited new blockchain series in Golang. I already have a complete blockchain series in Golang, a very long series about how to make a modular blockchain in Golang. But I decided to remake the series, and we're going to do a lot of things differently, right? Because in the previous series, we are using an account model, and I decided to use a UTXO model because I think it's very important to learn about that, because that's what the Holy Grail is using, and that's Bitcoin. The first episode is going to be free on YouTube. This episode, all the other episodes are going to be on my Patreon page. You need to understand that what I'm going to teach you is very valuable, because I worked for a very long time in the crypto industry. I won a lot of money by doing work, by winning bounties. So yeah, like I said, it's going to be it's not going to be these toy blockchains you're going to find on YouTube, all that garbage, you know what I mean? This is going to be the real deal. So the first episode is going to be free. The other episodes are going to be just on my Patreon page, where there is also a lot of other stuff to be found. So it's basically going to be worth your money. All right, so I'm going to quickly cover up what we're going to do. So we're going to call this project Blocker. Hey, if you find a better name, let me know. We're going to use the ED25519 crypto package for all our cryptographical stuff, private keys and all the shenanigans signatures. We're going to use a UTXO model. It's differently than the account model, but it's very important to learn, right? It's very, very important aspect. So that's something we're going to do. We're going to use protobuffer for our encoding. In the previous series, we were using our own serialization protocol, and I think I also changed it up to GOP encoding, which is the Go binary format. But we're going to use protobuffer. And for our gossip protocol, for the communication between our nodes or servers, whatever you want to call it, we're going to use gRPC transport, right? Because, hey, that's also being used in the industry for communication. So we're going to use that to make it robust, and also to make it more adoptable by, if you want to remake this protocol in some other language or something, right? And then we're going to use a proof of stake consensus. What is going to be yet? I'm not quite sure. I still need to investigate that. But hey, but I promise I'm gonna do it. I already did it. I already won some bounties with it. So hey, like I said, I know how to do these things, but just need to think about what's going to be a good fit. And there are so many things out there. I'm going to read some papers about it. Yeah, but that's for later on. So, cool. That's basically what we're going to do. Of course, there's going to be some sub things, some sub modules we're going to implement, but this is going to be an overview. Right, so let's get started. I already have this blocker project. It's basically just, let me open up it's nothing, right? It's just an empty project. I didn't do a go init and a go mod init and something. So it's basically a fresh project, right? And as you know, I'm gonna teach you stuff like I do, like I teach stuff. It's not gonna be, it's just gonna be me coding stuff and explaining things on the way, unscripted, raw and uncut. So you're going to see me make mistakes. But it's very important, because that's what you're gonna learn. That's what will make you learn things more easily, so you won't choke if you do that yourself, right? All right. So first of all, let me do a go mod init here. GitHub.com npm. Gonna be blocker. Boom. That's fine. And I think the first thing we're going to do is start with our private key shenanigans, because I think it's very important that we have private keys, public keys, addresses, signatures, because they are going to be embedded in a lot of other types, right? So I think it's going to be a good starting point. So we're going to make a new folder. I'm going to call this crypto. And inside of crypto, I'm going to make a new file. It's going to be, maybe we're going to call this keys go or something. That's going to be fine. I'm going to call this package crypto, just like that. All right, we're also gonna make a test, actually. Why not? Keys test go. Fine. Package crypto. Yes. Right. So we're gonna open up keys first. So what we're gonna do is we're gonna make private key. So we're gonna say type private key. It's gonna be a structure. Let's get this mouse cursor out of the way. All right, so we're going to make some wrappers around these ED shenanigans. So we're going to say key is going to be an ED private key. And this private key thingy will be just a slice of bytes, right? And the private key is going to be, I think it's going to be 64 bytes long. You're going to pub key, that's fine. Okay, cool, I'm just checking things out. So we're going to do this, then we're going to say func p, make some convenience functions, right? So we're going to say p private key bytes, that's what you're going to need, which is going to be return a slice of bytes. And it's going to be return p key. Then we're going to make p private key. We're also going to sign. Right? Because private key. Why do we need a private key? Private key is the keys you're going to hold on your system. You can never publish them, you can never make them public, but you need them to sign stuff, right? And we're going to cover that very soon. You need to have to sign your transactions and all that kind of shenanigans. So we're going to sign something, and what we're going to sign is a message. In our case, it's going to be transactions most of the time and blocks. But we're going to call this message, and this will return. It should return a signature, but for now we're going to return some slice of bytes. And what we're going to say is we're going to return p. No, it's going to be ed. Let me do this and check what's available. Sign. Let me see, and that's going to take in private key message. Yeah, fine. We're going to sign p key and the message, just like that. All right. The next thing we're going to do is find a way to get a public key. So what we're going to do is say type public key. It's going to be a structure. And that's going to be the same thing. We're going to say key is going to be ed255. It's going to be a public key, actually. Let's just tab complete this like this. So we're going to make a function in this private key. We're going to call this public, and that's going to return a pointer to a public key. The question will raise, do we need these pointers? Maybe we do, maybe we don't, because I don't think so, actually. But hey, let's start with these pointers. Like I said, I'm gonna do things like I think it's gonna be, and later on I'm gonna change things up, just the way it is. Just the way it is in production. Classic software engineering. This case we need to be careful because we cannot copy, we cannot basically just use the slice of bytes. Because wait, let me show you something, right? So we're gonna make some constants here. And we're gonna call this priv key len. And that's gonna be 64. Right? The length of the private key is gonna be 64 because it's gonna have the private key. The first 32 bytes is gonna be the private key, and then it's gonna append the public key on public key bytes appended, right? And so it's gonna be 32 plus 32 is gonna be 64. We're also gonna have a pub key bytes, pub key len, I mean. And that's gonna be 32. And then we're gonna have let me quickly think. I think that's fine for now. So I'm gonna make a buffer here, and it's gonna be make me a slice of bytes here of the pub key len. And then we're gonna copy B, the P key last. Let me open up this real quick. Let me open up this guy. You can do it like that. Is that true? It's gonna be the same thing actually. Why can't we not just do that? And then we're gonna return it's gonna say we're gonna return this public key thingy, and the key is going to be B. That's gonna be it. I'm just thinking if we cannot just use this. Wait, let me try something. P key public. What's gonna return this? X. Let me quickly see what this is. I see what's going on. It doesn't matter. We're gonna do it like that. It's fine. It's all fine. So we can have a public key. We can sign. That's all fine. So what I'm gonna do is I'm gonna open up here the keys test real quick. Func test new private. Actually, I'm gonna call this generate. Test generate private key. Let's see that I'm not coding in my window. It's gonna be testing.t, of course. So what I'm gonna do here is I'm gonna say priv key. I'm gonna say pk. Actually, priv key is better because pk can also be public key if you think about it. It's gonna be priv key. It's gonna be generate, right? So we're gonna make this function real quick. So we're gonna say func generate private key, which is going to return a private key. And we're going to say the seed is going to be make me a slice of bytes. It's going to be 32 actually. Let's make a seed len. Seed len is going to be 32. Seed len. And then we're going to say underscore r is going to be IO read full. We're going to give this a random reader. We're going to make a seed, right? And we're going to read into the seed bytes. And actually, you could say, why don't we return an error? I mean, if this fails, it fails, right? If this fails, there's no need to handle the error, right? The application is going to be broken. Your application, you're going to be wrecked. So we can panic here. So if there is an error and that's not null, you're going to panic, right? A lot of people say, yeah, you need to handle the error. If your program cannot continue, there is no need to handle the error, right? Unless you want to do something with it. But in this case, we can't. So then we're going to say something like and private key, like a pointer. Still need to think about these pointers though. Because you need to understand that this key is going to be a slice of bytes, which is already some kind of in memory. It's all kind of a reference to these bytes. So I don't think, but yeah, hey, we will see, right? Let's make this clean. Boom, we're going to return this private key. We're going to say that the key is going to be, I think it's something like ed new from seed. And it's going to be the seed here. Boom. Right? And then we're going to say, I just need to make sure that I'm not coding in my own window. It's going to be generate private key. Boom, just like that. And let me first install some cool stuff. We're going to say go get gitup.com stretcher testify. Boom. So we have this private key. We're going to say assert equal t priv key bytes priv key len. What's going on here? Priv key len. Of course, we don't have assert equal. We're going to say this and do it manually. Actually, sometimes the VS Code github.com stretcher testify. I think it's assert. All right, noise. Can we do this real quick? Go test -v. All right, it's working. What I'm going to do, guys, what I'm always doing is create a new file. I'm going to call this a make file. We're going to say build go build -o. We're going to say bin blocker. Then we're going to say run, which is going to build, and it's going to be ./bin docker. And then I'm going to say test. It's going to be go test. I think for both is fine. Just like that. Can we do a make test actually? Boom. That's fine. What I'm also going to do is pre-pending actually this add thingy, so we don't log out the commands. That's fine. Let's close this make file. All right, so test new private key. We're going to have this thing. That's fine. Then we're going to say the pub key is going to be priv key, pub key, public actually. Right, and then we're going to copy this assert thingy. I'm going to say len. We don't have pub key bytes. We're going to make this real quick. So, where's our pub key? Here. Func p public key. Bytes. Slice of byte. Return p key. So we're going to say len pub key bytes is going to be pub key len. Make test real quick. Boom, that's fine. Do we need something else? I don't think so. The next test we're going to make is func test priv key. Private key sign t testing dot t. So we're going to generate a new private key here, and then we're going to make a message, which is going to be, for example, foo bar bas, and then we're going to say that the signature is going to be priv key sign the message. Actually, it should be a signature, right? Because we need to verify this. What I'm going to do is I'm going to make a signature type. Signature is going to be a structure. We're going to say data. It's going to be a slice of bytes. Or value. And instead of returning, you're going to return a signature. What's going on here? Yes, signature. So we could do this. Return signature value. Something like that. And then we're going to say, see, actually the signature, I think I'm going to make pointers, to be honest. And actually we need to be careful because we're going to use proto buffer. So it could be that we're going to change things up. That we're going to make these proto buffer types directly. Not quite sure. That's going to be the next episode actually. Although a lot of this logic will be maintained, right? It's just we need to find a way to wrap it into a protobuf message. We're going to see. We're going to check that in next episode. It's going to be a signature. Signature. Bytes, that's what we need actually also. It's going to return a slice of bytes. So we're going to say return as value, right? Actually, yeah, it's fine. Then we're going to also say func as signature verify. Very important. We need a pub key, which is going to be a public key. See, I don't like this pointer. I'm not going to lie. And then a message. It's going to be a slice of bytes, and this is going to return a bool. And then we can say return ed verify. It's going to be the pub key. It's going to be the pub key key. the message. What's going on with this verify? Oh yeah, the signature, of course, it's ourself. I was just thinking. It's gonna be the message, and then we're gonna have the S value. That's the verify thingy. So now we're returning a signature here. So we could say assert true T actually wait. Yeah, it's fine. I think this equal should be reverted, to be honest, but hey, this is what it is. So we're gonna assert that the signature verify. Let's make a pub key. Let's make our pub key real quick here. So we're gonna say it's gonna be priv key. Public like this, and then we're gonna say verify. Help pub key. The message. That's fine. That's the only thing we need. Make test. Wait. It's gonna be cannot use signature. Yada yada yada. I think it's here. Yes, that's fine. I missed this. Okay. All right. So it's working. But of course, this is the true value. So what we're going to do is we're going to say here, assert false T sig verify pub key. We're going to make a new message. We're going to say there's going to be a message. What's going on here? Foo. Right? So that should pause here. All right, it's fine. So what we're testing is here. We are testing that if we sign the message with the pub key and we if we sign this foo bar bus with our pub key, with our private key, I mean, and we're going to verify it with the pub key, it's going to be valid. But if we give it a fake message, right? If we verify it with another message, it should return false, right? This is not a valid signature anymore. The next thing we could test is basically by saying here, we could actually say test with invalid message. Then we're going to say test with invalid pub key. So we could say something like let's generate a new private key. And then assert false T. And we're going to say pk, no wait, it's going to be sig verify with pk pub key, which is an other pub key. It's a fake pub key. Actually, let's say invalid. Wait, let's do let's make it clear. Invalid private key. Let's call it invalid. It's not invalid. It's basically, it doesn't matter. It's just another one, right? And it's going to be invalid priv key public. So we're going to say we're going to verify the message with the invalid pub key. And the message is going to stay the same, right? Make test. Boom. Right. So that's fine. So I think signing is already Gucci. Okay, so what we're going to do is we're going to make an address, right? And what is an address? You have private keys, you have public keys. Public keys can be shared publicly. That's why they call it public key. An address is basically a way to identify... it's actually just another representation of the public key. It is what it is. It's most of the time some kind of a hex representation of the bytes of the public key. Most of the time, just the first 20 or something. That's what we're gonna do. We're gonna use the first 20 bytes as our address. So what we're gonna do is let's make a type address. It's gonna be a struct. This is going to be some bytes. What we're going to do is... no, we're not gonna do this. We're gonna make this a string. We're gonna make this the stringer interface. We're gonna make this implement stringer interface so we could actually return hex encode to string, and we're gonna encode to string the value. A value, I'm thinking. And we're gonna say here, it's gonna be 20. So public key here, let's call public key, and we're gonna call address on public key, and that's gonna return an address type, and we're gonna return here, we're gonna return an address here where the value, I think, is gonna be p key len p.key minus address length. Yes. So we're going to take the last address length bytes, which is 20, of this address. So let's make a new test here. Public key to address. Testing T. So first of all, we need to have a priv key, right? Everything starts with a priv key. So we're going to generate one. We already have that function. Then we're going to say that the public key, we could say pub key actually to make it. We're going to say pub key is going to be priv key, pub key. So you see, we derive the public key from the private key. And then we're going to say that the address is going to, and then we're going to derive the address from the public key. Address like this. Then we're going to say assert equal, and we need to do this address len. It's going to be the length of the, actually we're going to do bytes here, to be honest. Address bytes. It's always nice to have, because if you need to do serialization or something. Slice of byte, and it's going to be return a value or something. So we're going to say address bytes. And you could see, let's print it out so you guys can see actually. Let's println. What's going on is println. And we're gonna just print the address. So the address is basically just a structure, right? This address thingy is just a structure, this one. But because we implement the stringer interface, it's gonna return this nice hex encoded string. I hope. So we're gonna say make test. You see? So this is our address, right? This is gonna be our address. What I'm gonna do is I'm gonna make something so we can deterministically test this. So we're gonna say here, func. New private key from seed Yeah. And the seed is going to be byte. And it's going to return a private key, which I'm still not sure if I want this pointer. I don't think so, actually, to be honest. I'm gonna change that up. Let's check this this thing real quick. We're gonna say if len seed is not equal to seed len, we're just gonna panic. Like I said, in this new generate stuff, I'm just gonna panic. And we could actually do a must generate private key from seed or something, but hey, we're gonna panic here. Invalid. Wait, I'm gonna say invalid seed length must be 32. Something like that. And in this case, we're gonna basically just return this private key. Where the key is gonna be ed new from seed, and it's gonna be the seed we give it here, right? That's what's gonna happen. I'm also thinking of making something from a string because can I do this? And you will see why. New private key. Private key. Hex decode. If add is not null. Let's just panic for now. If wait, and then we could do this. Yeah. B. You see? So we're gonna decode the string, and then we're gonna basically just return the new from the seed. So let's make a test here. Test. Let's do from string, because from string will also test the other one. What I'm gonna do is I'm gonna let's make a seed real quick. You will see why I'm doing this. We're gonna make a slice of bytes. It's gonna be 32. Fuck this. We're gonna just say rand read full rand reader seed. Encode the string here. What's going on here, man? Let's encode to string the seed. No, yes. IO. IO is this, not rand. IO read full. Let's print this out real quick. Boom, this is the seed we have. I'm gonna copy this thing. Like this. Right, so I have a seed, right? That's what I want to test. This is going to be the seed. And I'm going to say that the priv key is going to be new priv key from seed. But that's going to be from string, actually. Is this one. Assert equal. We're gonna say no. It's not gonna be. It's gonna be yeah. Assert equal. We're gonna say t priv key len priv key bytes, I guess. Whew. All right, that's fine. That's fine. So I want to quickly test. Priv key, public, address, print ln, address actually. Let me quickly run it here. Let me quickly see what I'm gonna do here. Assert equal. Did I actually copy this? Yes, I do. Okay, cool, that's fine. Let's delete this. Let's make a var here. Paste it in here. It's gonna be the address. This. I'm so sorry. I'm gonna make things clear. Boom. So that's the address string. First of all, we're gonna check this, this, and this. We don't need this address anymore. Then we're gonna say that the address string needs to be equal to the address we have. String version. Is that true? Help. Go test. Make test actually. All right, that's fine. I think we're Gucci. Yes. Yes. All right, so I think we have a lot of stuff in place, to be honest. So we have our private keys. I think we will go back and change some stuff up because I'm actually not quite sure about this pointer. I don't think we're gonna need it. A matter of fact, I'm pretty sure we're not gonna need it. Not quite sure why I did this. So we're gonna change that up. Yes, because like I said, pointer to the signature, it doesn't make any sense, right? It doesn't make any sense, especially not because we have the value already. Let me see here. You see we have already this this byte thingy, because this is a byte already sitting in here. There's no need to make a pointer. So we're gonna change that up. Like I said, it's gonna be a good starting point. The next we're gonna do is install proto buffers and all that stuff. So we're gonna make blocks, transactions, we're gonna make our UTXO model and all that stuff, and we're gonna continue from there. This is gonna be free on YouTube. All the rest is gonna be on Patreon. Check that out. Jump into my Discord community, subscribe to my channel if you have more questions about this. And like I said, thanks for watching, and I'm looking forward to see you in one of my live streams or future videos. Peace out.